Hello, dear students. Welcome to GATE surveying class. In the previous class, we discussed the introduction of surveying, and in this class, we are going to discuss about compass survey. Compass survey is an angular measurement which can be recommended whenever linear measurement is not possible. These are the basic terminologies which are used in compass survey. In compass survey, there are two compass. One is prismatic and another one is surveyor compass. Prismatic in the prismatic compass, you can get the graduation 0 degree graduation at south, 90 degree at west, 180 degree at north, 270 degree at east, and 360 degree at south. It is in clockwise direction. But in case of surveyor, the readings are represented 0 to 90 degree with respect to either north or south. If it is north, the angles are noted as north to east or north to west. Similarly, south to east or south to west. Whole circle bearing system and reduced bearing system. These two systems are used to note down the reading in compass survey. WCB, whole circle bearing system, is adopted in prismatic compass. Reduced bearing system is adopted in surveyor compass. Sometimes the reduced bearing system is also known as quadrantal bearing systems. Whole circle bearing system, mention the reading from 0 to 360 degree, but in case of reduced bearing system, the values are ranged from 0 degree to 90 degree. Okay, we will see the exact picture in the problem. I will explain later in detailed manner. First, what is a true meridian and what is magnetic meridian? True meridian nothing but which is an axis passing through geographical north pole to and geographical south pole. Similarly, magnetic meridian nothing but it is an axis which passing through magnetic north to and magnetic south. Our compass, either prismatic compass or surveyor compass, have magnetic north as well as magnetic south. So the axis passing through these two north and south pole is known as magnetic meridian. Meridian means axis. Next, true bearing and magnetic bearing. Bearing nothing but angle. The angle between true line and um, true meridian is known as true bearing. So true bearing nothing but the horizontal angle. The horizontal angle between surveyor line and true meridian. True meridian nothing but which passing through GNP and GSP, that is north pole and south pole of the earth. Okay, so true bearing is the angle between surveyor line and true meridian. Magnetic bearing nothing but it is an angle between magnetic meridian to surveyor line. The angle between survey line and magnetic meridian. Okay, so we know what is magnetic meridian. Next, declination. Declination nothing but the error due to some reason. Okay, the error happened either maybe instrumental error or manual error. Mainly declination nothing but declination is the error made by uh, instrument. The instrumental error, declination nothing but instrumental error, which may happen either eastern direction or western direction. Okay, for example, in particular case, the compass showing 4 degree in eastern direction, this is called as eastern declination. Actually it should coincide with true meridian. It means that the magnetic needle should coincide with true meridian. Instead of that, the needle have the declination means it shows the value with some errors, say 2 degree, 3 degree, or 40 minutes, 50 minutes, whatever it. Okay, if needle is deviated with respect to true meridian towards western direction. This is called as western declination. Okay. So this is a declination. This is a useful terminology. It has to be used in our problem. Next, isoclinic line and agonic line. Isoclinic line, nothing but it is an imaginary line which connects equal declination on the earth. Equal declination on the earth. Agony line, nothing but agony line, also imaginary line which connects zero declination on the earth surface. And dip, so dip nothing but vertical angle. So declination is a horizontal angle, dip is a vertical angle between magnetic north and surface, ground surface. So dip is the vertical angle between survey line and ground surface. Okay, that is magnetic needle and ground surface. Next, local attraction. Local attraction, it is an error. Local attraction is an error when there is a no difference, when there is a difference between forebearing and backbearing is not equal to 180 degree, it means that local attraction takes place. Local attraction nothing but local attraction occurred in the vicinity of magnetic substances, iron ores. These iron ores may be available in the survey area where we are conducting survey, compass survey. So our compass made with magnetic. So this magnetic needle is influenced by iron ore or electric wire and some other presence of magnetic substances. And if we found difference between forebearing and backbearing is not equal to 180 degree, we can say that there is a local attraction occurred. Next, now you can get clear idea of terminology from this figure. So this is our earth. Magnetic lines are originating from geographical south pole and moving towards geographical north pole. So this is our magnetic lines. Okay, earth magnetic lines. So this is true north and this is true south. The axis passing via true north to true south is known as true meridian. See here, picture this line. This is true meridian. Okay. Next, so true meridian here. This is considered as true north, and this is true south. Okay, which exactly coincides with our Earth North Pole and South Pole. Next, this is survey line. This is survey line for which we have to conduct the survey, or we have to measure this line, or we have to measure the angle. Okay, the angle between true meridian and survey line is known as true bearing. Let us imagine. So this is what true meridian, and this is survey line, which is lies on ground surface. Now we have to measure the angle between true meridian and survey line. This is called as true bearing. Bearing nothing but angle. Okay, but so true north lies on ground. Survey lines lies on ground. Come to here. This is magnetic north and magnetic south. So this axis is called as magnetic meridian. So this magnetic meridian is available at prismatic compass or surveyor compass, not on ground. Okay. So with the help of compass only we are going to measure the bearing. Okay. So if the angle between magnetic meridian and survey line is known as magnetic bearing. Okay, so now you can you can get the clear idea. Okay, now you can see the difference here. So this is true north and true south, and this is magnetic south and magnetic north. The angle, the okay, actually it has to be coincides with the true north. Instead of that, it has some variation. This variation is called as declination. Okay, so this is magnetic north and magnetic south. Next, this is our survey line. Now I am getting some value. Now I am getting some value in my compass. That angle is called as magnetic bearing. Already we discussed magnetic bearing, nothing but the angle between magnetic meridian and survey line is known as magnetic bearing. Next, true meridian. So true the angle between true meridian and survey line is the true bearing. This true bearing is required for our engineering purpose. Hence, we have to find true bearing. But with the help of instrument, we are getting magnetic meridian. And similarly, you can get with the correct instrument, with the correct exact instrument, you can get the declination. So, okay. So in order to get the true bearing, the summation of declination and magnetic bearing is true bearing. See here, true bearing, summation of magnetic bearing plus eastern declination. This declination is called as eastern declination because this magnetic needle lies towards the east side. Hence, it is called as eastern declination. Okay, come to this picture. This is true meridian, survey line. If magnetic needle lies on the western direction with some error, with some variation, this variation is called as western declination because it is lies on the western direction. Okay, on western side with respect to true north. Okay, uh, so this is survey line. Now I am keeping the same survey line. See here AB. This is I am keeping the same survey line. Suppose magnetic needle lies on in this side, on this side, on this side. Okay. So that time I am having the magnetic bearing because with the help of instrument I can take the reading. I can take the reading. That reading is known as magnetic bearing. Magnetic bearing nothing but angle between magnetic meridian and survey line. Okay, this is magnetic bearing. But for engineering purpose, we have to use true bearing. We have to use true bearing. So true bearing is nothing but angle between true meridian and survey line. So what is the angle of survey line with respect to true north? Okay. So now we have magnetic bearing and we as well as we have western declination. So magnetic bearing minus western declination gives true bearing of survey line. Okay, so this is applicable when magnetic north is lies on western side. Okay, so this is basic ideas. Next, whole circle bearing, actually azimuth nothing but angle. Okay, the whole circle bearing system is used in prismatic compass. Look here. So this is for say, let us consider this station is A. Let us consider this station is A and this station is B. Now I am looking the point B with the help of instrument from A. The corresponding angle is theta 1, which is called as forebearing. And similarly, I can look the point from B to A. This is called as back bearing. If you find the difference between forebearing and forebearing and back bearing is 180 degree. If it is exactly 180 degree, there is no error. See here theta 1. If you extend mathematically, if you extend here, so this line also one theta 1. Okay, but with respect to north, this is 180 degree. Okay, so if you extend here, this is theta 1. Similarly, this also theta 1. Hence, so back bearing nothing but 180 degree plus theta 1. Okay, so theta 1 forebearing, theta 2 nothing by 180 degree plus theta 1. So theta 2 minus theta 1 is equal to 180 degree. It means that there is no local attraction. Okay. Next,